Hey there, this is Mrs. Lemke, and we are going to go through the last lesson of Unit 4 today, which is about probability trees. So in a similar fashion to the way that Venn diagrams help you to picture a problem in terms of probability or the ways that sets are related, probability trees can also help us figure out probabilities. We had a problem earlier that had used probability trees as well, so you've seen this a little bit already. We're just going to formalize it in this lesson. So the first question, oh, I forgot to say this. There is a notes page. And so if you have a printer, you could go ahead and print it. If you don't have a way to print it, like I don't have a printer at my house, I understand that. Just look at the PDF and write down a few things. We are not actually going to do all the problems, so to save yourself some writing time, those of you without a printer, we're going to do problem 1, we're going to do problem 2, problem 3, and problem 5. And I believe that's it. Yes, that is it. Okay, so that is what we have ahead of us. So those of you who need to make your own notes, please pause the video, make your own notes, come on back, okay? So our first question is just defining what a sample space is. So this has been covered in other lessons, so hopefully this is a review question for you. A sample space is a listing of all of the possible outcomes for a particular event. So if I were rolling 2 dice, then my sample space would be that picture that we had the other day where we had, it's like a 6x6 picture of all the different ways that the dice could be rolled, right? And so I had like snake eyes here. Oh gosh, that's really bad writing. I'm just going to use numbers. They had like rolling a 1 and a 1, rolling a 1 and a 2, rolling a 1 and a 3, etc. And then going the other direction, right? It had this. Right, this is the sample space. I don't want to have to write it off, okay? So it had like 36 different ways of rolling a pair of dice. That's a sample space. So a probability tree helps you to write out that sample space in case you're having a hard time conceiving of it. So the second question says draw a tree diagram to create the sample space of the genders of the children if the family has 3 children. Now, this question admittedly is a little simplified just for being a math problem. We are just going to think of gender as being binary, and I know that a lot of theory says that that is not true, but just for the sake of being a math problem, that is how we're going to think of it. So let's just suppose that each child is labeled a boy or a girl. And so this part of the branching is that first child. I'm going to put the second child in red. So if my first child was a boy, the second child still could be a boy or a girl. And if the first child was a girl, the second child has those options as well. And then my third child, I'm going to put that in green. You see how at each phase we are drawing more and more and more branches because there are more pathways to get to that location. Each of these sets of branches is just 2. Okay, and now if you trace through the diagram, it's possible to write out the whole sample space. So for instance, this pathway is the family that has 3 boys. This pathway, maybe I should show that in a different color. Sorry about that. I'm trying to think of how to demonstrate this well. This pathway. Oh, I don't know why that's straightening. That's really weird. Is that bothering you? Is it bothering you that I'm taking time to redo it? Okay, see, why? Why did that not straighten out? I'm so baffled. Technology. Oh my gosh. Okay, so that pathway that I just highlighted in blue is boy, boy, girl. Then the next pathway would be, I can't, I'm not going to end up here or here. I'm going to have to end up here, right? I'm just trying to go down this line. So that would be boy, girl, boy. Okay, and then to end here, I'd have to take this route. Okay, and then I hope that you can do the rest. So since we just did half the diagram, right? You can see like right here, I've done those 4 outcomes. You can see I have 4 more outcomes to do. Now, I have had students in the past who really struggle with this. So for that reason, I'm going to ask that you pause the video, try to write out the next 4, and then come back in a minute, okay? Maybe that seems silly, but like I said, I've been a stats teacher for like 10 years, and I know that sometimes people have a hard time with this, okay? So just take a second and make sure that you're not one of those people by practicing it. Pause. Okay, welcome back. So this is the rest of the sample space, or those bottom 4. If you did the listing in the order that my diagram was created in, like in this order, this one, and then this one, and then this one, and then this one, then your list will be in the same order as mine. If it's not in the same order, it's not a big deal. You just don't want to miss one of them, right? And forget to write it down and then think your sample space only has 7 elements when it actually has 8. Now, that does take a little bit of doing, right? That did take a little bit of effort. But the great thing is that now we can use our sample space to find all of these probabilities. Now, we talked before about how if these branches were not equal in likelihood, what we would do is we would put probabilities here. Like, let's say that the probability of having a boy was 60% and having a girl was 40%. If that were the case, then I would incorporate those probabilities into my diagram, and I'd find the probability of these outcomes by multiplying together those numbers. Now we are, like I said at the start of this question, this is a very simplified situation, okay? Gender binary, we're going to say that girls and boys are equally likely, which isn't actually true biologically. It's a little bit more likely to have a boy than a girl. But we're just going to say it's 50-50. Okay, so if every one of these branches is a 50-50 shot, then each of these 8 outcomes is equally likely. Okay, so I can just use that idea, because if everyone is like a coin toss, then each of the resulting outcomes in the sample space is going to be the same probability. So it says here, find the probability that the family has exactly 2 girls. Okay, so if they have 3 kids, what's the probability of ending up with 2 girls? So I'm going to look through here. Here's an outcome that has 2 girls, and here, and here. So for this answer, I would say, well, there's 8 elements in my sample space. 3 of them have 2 girls. The next one says, what's the probability that my 3-child family has 3 boys? Well, there's a way to have 3 boys, and every other option has at least 1 girl. So that's going to be just 1 out of 8. And then I kind of hinted at this next answer, a family that has at least 1 girl. Well, all of these have at least 1 girl. It's the complement to the previous question. So not having any girls and having some girls, those are complements of each other. Remember what I mean by complements is that the 2 of them together cover 100% of the cases, cover the whole sample space. So some versus none, those are opposites. Some girls, no girls. All right, this question. So suppose a box contains a $1 bill, a $5 bill, and a $10 bill. A bill is selected. You look at what kind of money it is, then you put it back in the box, and then you pick a bill again. Draw a tree diagram to determine the sample space. So the first draw out of the box, I'm going to draw the single, the 5, or the 10. If I draw the single, can I draw the single a second time? I can, because it said replaced. Now, if it said not replaced, then I'd only have 2 possibilities in this next draw. I will have the 5 or the 10 because I already took the 1 out and I kept it. Okay, same thing here. I put that first bill back in. Same thing here. I put the 10 back in. I could draw the 10 again, or the 5, or the 1. Okay, so if I were writing out the sample space, I'm going to have 9 options. I could draw a 1 with a 1, a 1 with a 5, a 1 with a 10, 5 and then 1, 5 and then the 5 again, 5 and then the 10, a 10 and then a 1, a 10 and then a 5, the 10 drawn twice. That's my sample space. Okay, now these questions, I think you can answer these based on the sample space we just wrote. I would like you to do that. Okay, so pause the video and I'd like you to answer those next questions based on this sample space that you see. Okay, I think I'm going to leave this slide here with the questions. Pause, work them, come back. If you didn't pause, you're cheating. Okay, welcome back. So I have my answers here. So both bills have the same value. It's just when you have doubles. So 1, 1, 5, 5, 10, 10. That's 3 different ways out of the 9. The second bill is larger than the first bill. That's these 3 outcomes. The value of each of the 2 bills is even. Well, the only even number involved in the problem is 10. 1 is odd, 5 is odd. So the only way to have 2 evens is double 10. This next one said exactly one of the bills is odd. So you have to have a 10 with something else. And so these are the 4 different outcomes that had 10 with something else. And then the last one asked us to figure out adding up to less than $10. So in blue ink here, I wrote down what each of the sums was. Like if I have 1 and then 1, that's $2. And so the things that are less than 10 would be this one, this one, this one, and that's it. Equal to 10 is not less than 10. So that's it. All right, number 5. Let me look back at that. Yeah, okay. Number 5 is the last one we're going to do. Person is purchasing a new vehicle. Oh, that sounds great. I kind of in the mood for a new car. Maybe that's why I want this question. Okay, so a person is purchasing a new vehicle and can select one thing from each of these. So they can get an Accord, a Civic, or a Pilot. They can pick the seats to be cloth or leather, and they're either going to get a white car, a blue car, or a silver car. So for this part, I want you to draw a tree diagram. I haven't really forced you to make the tree diagram on your own yet, so I'd like you to try to do that, okay? Again, I want you to pause the video. I'm going to show this part of the screen so you can take a look at it as you pause. The first set of branches is going to have 3 branches, then 2 branches, then 3 branches. Let's do it that way, okay? Take a minute, pause. Okay, so I just reminded myself of the downside of these tree diagrams because, ooh, this got a little like crunched, right? You had to try to fit in 18 branches and like, look at this. This looks kind of messy. To be honest, like I'm a little like too lazy to write out all of this, okay? But if you did write out all the sample space, like good on you. That's awesome. Okay, so there were 3 different models. There's 2 different kinds of seats. There's 3 different colors. So I know I'm going to have 18 options, okay? I can see them in the diagram. I don't know that I absolutely have to write the sample space. I think I'm okay. But if you're not, you should write them, right? You have to get the questions right. All right, here's the questions. I already did them. So I'm just going to explain how I got them. So the first one said, what's the probability that a randomly selected car from this scenario has cloth seats? So cloth in my diagram was this CL. And that meant 1, 2, 3, 4, 5, 6, 7, 8, 9 cars were attached to cloth in the diagram. So 9 out of 18. Is a silver Accord. So Accord was the A. And then silver attached to the A was those 2. So it's 2 out of 18. That's what I mean. Like you can kind of see it in the picture, right? Even if you didn't write it all out. A blue Pilot with leather seats. Now that's very specific. So a blue Pilot, so here's Pilot, and blue and leather. That's only 1 car, right? Up here, the blue would be attached to the cloth seats. So that's just 1. Is white. All right, so white would be here, 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 and here. So that's 6 out of the 18. And is either a blue or a silver Civic. So a Civic was this one, and blue or silver would be 1, 2, 3, 4 attached to Civic. So that's 4 out of 18. So I would anticipate being able to do this sort of problem. Someone today asked me about the test for this unit, and I had to kind of chuckle because as of the time that I'm recording this, I don't know what your test is going to be like. I haven't made it yet. Online testing, such a trick. But maybe like by the time that you're watching this, maybe I have an idea. So I'm kind of thinking that maybe one of these with a tree diagram would be kind of cool, right? Having to draw a tree diagram and figure out some probabilities. I think that's something you should be able to do. I have to think about that. All right, so for today though, you should do the problem set that goes with this. This is the end of this unit. So we are up to, like, next week we'll be reviewing, taking a test fairly soon. We're also winding up your project, so a lot of things are sort of finishing up, and then we'll have our last little sprint to the end of May, okay? We'll have a little bit more of a study of probability in Unit 5, okay? Make sure that you communicate with your project group, and make sure you signed up today for a conference time with me online next week. I just want to do a little check-in with each of your groups, kind of see where you're at, see what graphs you've made, see how you're feeling about like manipulating the spreadsheet and such. I don't want to leave you high and dry. I want you like ready to like make slides and such. And then we'll have that conference time. And then a week after that or so, I think we'll have you do the same sort of thing, have another conference time with me, but that conference time won't be a conference. It will be your group presenting via Google Meet, Google Hangouts. Okay, so that's kind of what I'm thinking. Please reach out at any point if you're confused or just don't understand, or your project group is being horrible and you're having to do all the work. I should know about that. So don't hesitate, okay? You guys keep rocking it out. You're awesome. Thanks.